Today we are going to get back to working with parabolas, and specifically today graphing parabolas. We've graphed quite a bit this year, but we've always graphed linear functions, which means we always ended up with a straight line. But we know from what we've talked about already with parabolas or quadratic functions, that is anything with an x squared term, when we graph it, we are not going to end up with a straight line, but we're going to end up with a parabola, which is this shape right here on the graph. And what they've done here is they've graphed the function f of x equals x squared minus 4x plus 5, and that's the graph that they ended up with. But where did all of this come from? How did they get that graph? We're going to go through those steps right now. So when it comes to graphing a parabola, this equation right here is going to be extremely important. X is equal to negative b over 2a. That's going to tell us where the location of the axis of symmetry is, this dashed line. We know the axis of symmetry cuts the parabola right in half. So what they did is they substituted values of b and a. Now where did those come from? The coefficient of x squared, which if we don't see a number there, like here, it'd be a 1, right? Whatever's in front of the x squared term is a. Whatever's in front of the x term is b. And the constant at the end will always be c. And for today, we're not really going to be real worried about the c value. We're going to be looking at a and b. So I'm going to use that formula, negative b over 2a, and I'm going to substitute in those values. So my b value is negative 4. Now notice I'm going to end up with a double negative here. So I have a negative 4 over 2 times, and a was 1. By the time I simplify that, we're going to end up with this right here, 4 over 2, or 2. I know that the axis of symmetry, the middle of my parabola, is going to be right at x equals 2. So we're going to take this value, and we're going to start by substituting it into a table. And it's always going to go right in the middle. I always want my vertex to be right in the middle. And then they just finished filling in the x column by putting two numbers smaller than 2 and two numbers bigger than 2. Right, so we have consecutive numbers. But we have to figure out the y values that go with them. How did they know that when x was 2, y was 1? They used our function. F of x equals x squared minus 4x plus 5. I'm going to take that function, but I'm going to replace the x with what it's equal to. It's equal to 2. So I have, instead of x squared, I have 2 squared minus 4 times x, but instead of x, I have 2 plus 5. I took this function and I replaced the x with a 2. Now notice, every time they replaced x with 2, they put it in parentheses. So you really could just grab a calculator, type this entire expression into the calculator just the way it looks here, and when you do that, you're going to get 1. That's where the 1 value came from. That tells me that my vertex lands right at 2, 1, this point right here. And then they just repeated that process. They put a 3 in for x, then they put a 4 in for x. Now notice what happens. If we set this up correctly, this should be symmetrical. They did not have to evaluate for 3 and 1, because notice 3 and 1 have the same answer. Same thing with 4. Once they figured out the value for 4, when they put in 4, they got 5. And that also told them the value when x is 0. So let's try one of these on our own. Go ahead and flip your note sheet over. Let's look at the other side for a minute, and let's do this example right here together. So when I look at this expression, I can see that my a value, again, is going to be 1. My b value this time is positive 4. My c value, again, which I'm not real concerned with, is 3. So let's take our formula, negative b over 2a. And for a, I'm going to put in 1, and for b, I'm going to put in 4. So I end up with negative 4 over 2 times 1, or negative 4 over 2, which would give me a value of negative 2. I know my axis of symmetry is going to be right at x equals negative 2. So I'm going to take this value, I'm going to put it in my table right here in the middle, negative 2. And then I'm going to put two numbers smaller than negative 2. So negative 3, negative 4. Then I'm going to put two numbers bigger, negative 1 and 0. Now I need to start to fill in the rest of my table. How do I know the y value that goes with -2? I'm going to take my function x squared plus 4x plus 3. I'm going to replace the x with -2. So I have -2 squared plus 4 times -2 plus 3. Again, I could just grab a calculator, type that whole expression in, but -2 squared would be 4. 4 times -2 would be -8. So 4 plus -8 plus 3 would give me a value of -1. When x is -2, y is -1. Okay, we need to repeat this process. So I'm going to get rid of this for a minute, give myself some more room here. We're going to do that same thing over again, but this time I'm going to substitute in -1. So now I'm going to put -1 in parentheses squared plus 4 times -1 plus 3. Well, -1 squared would be 1 plus -4 plus 3. This is going to give me a value of 0. When x is -1, y is 0. Now remember, this is symmetric. So if -1 is 0, that also means -3 should be 0. You can try that out and check it if you want. And then let's do this one more time. Now I'm going to replace my x with 0. Same function at 0 squared plus 4 times 0 plus 3, which will give me a value of 3. So when x is equal to 0, y is equal to 3. Again, this is symmetric. So if 0 is 3, -4 must also be 3. Now I've got my 5 ordered pairs that I can plot on the graph. Let's, just like we filled in the table, let's start in the middle. I want to know where my vertex is going to be. My vertex should be at -2, -1. Okay, now I'm going to go to -1. -1, 0 would be right here. And I'm going to work my way out. -3, 0, because they should be symmetric. Then I have an ordered pair at 0, 3. And I also have something at -4, 3. And you can see that my 5 points form a U shape. Now I'm going to draw my curved line through those 5 points. And I've just graphed the quadratic function x squared plus 4x plus 3.